Hi, I'm Fiona Carroll, and I'm doing Khan Academy 18.1 from the Thermodynamics and Free Energy chapter. Looking at the problem, the hydrogenation of ethene to create ethane was determined to occur by way of a multi-step mechanism. Give the reaction steps below to determine the sequence of reactions that yield the equation above. Indicate whether each individual step is endothermic or exothermic and whether the products are more or less ordered than the reactants for each of the individual steps as well as the overall reaction, and calculate the Gibbs free energy in the product at 185 degrees Celsius and indicate whether at this temperature the reaction occurs spontaneously. So, looking at part A, we are given the reaction steps and the overall reaction. And what is asked is how those steps become the overall reaction. And how we're going to do this is we're going to multiply each of those steps by a coefficient and or flip the direction so that anything that's not in that overall reaction will cancel and anything that is in the overall reaction will have the correct coefficient. So the first one we're going to multiply by 1/2 to cancel out that 2 on C2H2 so it becomes a 1 like the overall reaction. Second one we'll multiply by 1/2 to cancel out that 2 so that C2H6 has a coefficient of 1. Third one we multiply by 2 so that H2 has a coefficient of 2 like the overall reaction. And also on the second one we're going to make sure that we reverse that direction because C2H6 is in the reactants there and in the products in the overall reaction. So we're just going to write out each of these steps, making sure that we multiply through all of those coefficients and the direction on the second one is reversed. And we're going to add them up, canceling out anything that's balanced on both sides. So that's the oxygen, carbon dioxide, water. And then we're left with the overall reaction. And so these indeed are the steps that will get us to that overall reaction. So on part B, we are being asked whether each individual step is giving off or taking in heat. We're going to stick to that first half to determine that first. And so how we're going to approach that is to manipulate delta H in the same way as we manipulated those steps. Add up all of those steps to get the overall delta H, and then look at the signs of the steps and that overall to determine whether energy is being given off or taken in. In addition, delta H is given in units of kilojoules. So looking at this, we multiplied the first reaction by 1/2, so we're going to multiply that delta H by 1/2 to get a negative value. We're going to multiply that second one by negative 1/2 because in addition to multiplying the second equation by 1/2, we also reversed its direction. And then we're going to multiply the last one by 2 because we multiplied that last reaction by 2. And these are the values we get. The first one is negative, meaning energy is being given off and it is exothermic. The second one is positive, meaning energy is being taken in and it is endothermic. The last one is negative, meaning energy is being given off and it is exothermic. Delta H overall is just going to be these steps all added up. And once we add them up, we get a value of negative 312 kilojoules. And that is a negative value, meaning energy is being given off and it is exothermic. So looking at the second half of this, what is being asked? We are being asked what the entropy is like for each of these steps and for the overall reaction. And that will mean determining the sign of that entropy to determine whether or not the delta S is increasing or decreasing. So what is given here is the reactions from earlier, and entropy is in units of joules per Kelvin. And how we are going to do this is we're going to add up the values from the back of the book for each of those compounds, and we're going to use a format of products minus reactants for each of those reaction steps. And then we're going to finding the entropy for change in entropy for each of those reaction steps. And then we're going to add up all of those steps to determine the overall entropy and look at the sign of those steps of the entropy of the change in entropy of those steps and the change in entropy of the overall reaction to determine whether the products are more or less ordered than the reactants. So here's the first one. We're going to find those values in the book. If it's a reactant, it's going to be negative. Remember, products minus reactants. And we're also going to make sure that all those coefficients are multiplied in, add up the values, and this is a negative value of entropy, meaning entropy is decreasing. Do the same thing for that second equation, add up all those values, and entropy is a positive value, meaning entropy is increasing. Same thing for the last one, add up all those values, and entropy is a negative value, meaning entropy is decreasing. And looking at that, entropy is decreasing, that means disorder is decreasing. So that means in the first one, the products will be more ordered than the reactants. In the second one, because entropy is increasing, the products will be less ordered than the reactants. And in the third one, because entropy is decreasing, the products will be more ordered than the reactants. So now to get delta S overall, we're just going to add up all of those steps. And once we add up those steps, we are left with a value, an entropy value of negative 233.1 joules per Kelvin, and this is negative, meaning that entropy is decreasing and that the products will be more ordered than the reactants because disorder is decreasing. Cool. So, looking at the last one, Part C, we are calculating Gibbs free energy in the product at 185 degrees Celsius and indicating whether at this temperature the reaction occurs spontaneously. So to do this, we are being asked, what is the change in free energy and will the reaction go spontaneously on its own? And we will use the values that we calculated earlier and also the 185 degrees Celsius that is given in that question that this reaction is occurring at. The approach to doing this is we're going to use the Gibbs free energy equation and the values we calculated in the other parts to calculate delta G, and then we'll look at the sign of delta G to determine spontaneity. So delta G equals delta H minus T delta S. Delta G is free energy, delta H is change in enthalpy, T is temperature, and delta S is entropy. So we're going to add 273 to that 185 degrees Celsius to convert it to Kelvin, and then just plug in the values from before, making sure that that entropy, because it's in joules per Kelvin, we're going to convert that into kilojoules per Kelvin so that all the units cancel. We get a negative value of delta G, and this means that delta G is spontaneous, or the reaction is spontaneous, apologies. And so to go over what we did in this problem, we determined the sequence of reactions that yield the equation above. We determined whether those steps were exothermic or endothermic, and whether they, or what the sign on entropy was. And then we determined the spontaneity of the reaction and the Gibbs free energy. Thank you.